So we're going to go ahead and start our next section, which is 5.6, which is about the indeterminate forms and something called L'Hopital's rule. So we're talking about indeterminate forms, which means we're going back to talking about limits. So recall from limits the forms 0 over 0 and plus or minus infinity over infinity are called indeterminate forms. So remember, if we get 0 over 0 or plus or minus infinity over infinity, that doesn't tell us what the limit is. We still can't determine it. And so let's revisit some of those examples that we've looked at in the past. So for example, the limit is x goes to -1, 2x squared minus 2 over x plus 1. If I plug in -1, I'll get 0 in the top and 0 in the bottom. So the way we dealt with this before was we would factor, because this is a polynomial over a polynomial, we could factor the top. You pull out a 2, and then it'll factor as x minus 1 and x plus 1. And then we would cancel these x plus 1s here. So then I'm looking at the limit as x goes to -1 to x minus 1. Now you can plug in -1 and you'll get 2 times, you'll get -4 for that limit. And let's look at one more example like we've seen in the past. So let's do a limit at infinity. The limit is x goes to infinity of 3x squared minus 1 over 2x squared plus 1. So in the top I'm getting infinity. In the bottom I'm also getting infinity. That's another indeterminate form. So what we did here is we multiplied top and bottom by 1 over x squared. So we're just multiplying by 1. We're not changing anything. And so we'll get 3 minus 1 over x squared over 2 plus 1 over x squared. And we got 3/2 for this limit. So that's how we dealt with these limits previously, is we would either factor them like the first problem, or in this case we multiplied and simplified till we could calculate an answer. But now what we're going to do is we are going to learn a new method for calculating these limits. Using something called L'Hopital's rule. All right, so let's go over what exactly is L'Hopital's rule. So it says let f and g be differentiable functions if the limit as x goes to c of f of x over g of x has the indeterminate form 0 over 0 or plus or minus infinity over infinity, then the limit as x goes to c of f of x over g of x equals the limit as x goes to c of f prime of x over g prime of x, provided the limit on the right exists. So if I want to compute this limit over here, and it's 0 over 0, or plus or minus infinity over infinity, I can compute this other limit with the derivatives and see if I can calculate that limit instead. So we're going to look at a few examples using L'Hopital's rule.